Hello, my name is John Mason and I'm a senior chemistry and chemical engineering dual degree at Widener University. Today I'll be talking about my research involving a microwave synthesis of a metal organic framework, copper BTC. Metal organic frameworks are metal ions with organic molecules that link them together. They can be used for gas capture, water purification, catalysis, and various other applications. The picture on the left shows a molecule of copper BTC. The yellow balls are large molecules that are captured by the copper BTC. The green molecules represent significantly smaller ones that are also captured by copper BTC. In this research, an alternative synthesis method was used to create copper BTC in a greener method. This was achieved using a microwave synthesis using 3 different temperatures and 3 different reactants. This is then compared against the solvothermal method, which takes place over an 8 to 16-hour period and requires significantly more solvent. For our synthesis conditions that we used, there were 3 temperatures, including 150, 170, and 185 degrees Celsius, as well as we used 3 different reactants: copper nitrate trihydrate, copper acetate monohydrate, and copper acetate. They were reacted in an ethanol and water mixture in an Anton Par Monowave 400 microwave synthesis reactor at their desired temperatures for 10 minutes. This is a significant reduction in time and temperature compared to the traditional synthesis method. In order to confirm copper BTC, we used X-ray crystal diffraction, or XRD. Going from top down, we have our copper nitrate sample, our copper acetate monohydrate sample, our copper acetate sample at 170 degrees, our copper acetate sample at 150 degrees, and at the bottom is our copper acetate sample at 185 degrees. Looking at our samples, they all match up except for the first line in the first sample. This is believed to have happened due to water of hydration in the last 4 samples that was not present in the first one. When compared to literature values, the first reaction was very close to what we found copper BTC to be. The following ones were closer to copper BTC monohydrate. Next, we tested the thermodynamic stability of copper BTC. Using a thermogravimetric analysis, we checked the stability between 20 and 400 degrees Celsius. We found that our compound was stable up to around 350 degrees. This is really important because then we know if it's used in gas capture or in other reactions, it needs to be around, it cannot go above that temperature or it will begin to decompose. Finally, we observed the yield of our reactions. All of our reactions had very comparable percent yields. Our samples did not really differ based on the reactant or the temperature. So the final thing that we need to know in order to tell if there was a difference is the porosity of our molecules, which is currently being tested for. I hope to see you guys at our poster presentation next week. Thank you.